This question is about the photoelectric effect in which we are given the three scenarios. The metal plate is same, but in a first scenario, if the photon, if you throw a photon of a monochromatic light means single wavelength light, such that its frequency is f, and you see it is falling and hitting this electron, so this electron will instantly eject, which means that this frequency is ejecting an electron, and this is now a free electron, a photoelectron. In this question you have to find out the kinetic energy of this electron when we will throw a photon of 4f frequency. But in this question, when this energy of light is hitting the photon electron, it is giving its complete energy to the electron, but this electron is not having any kinetic energy while it is coming out, so its kinetic energy is zero, which means that all the incident energy hf is equals to work function according to photoelectric effect, and there's a no Emax, no kinetic energy. And now let's repeat the same scenario, but now let's throw a light of the frequency 2f. So this is light of a green photon of a green light, which has a energy of h into 2f, which has a more energy than a red light. So of course it will eject electron, hitting the electron, and electron is coming not only out of this metal plate, but now this electron is moving with the kinetic energy k according to this question. So if we apply the photoelectric equation, so incident energy is 2hf is equals to work function is specifically constant for this same metal plate, is not going to change, plus this is the maximum kinetic energy, which is k. Okay, in the scenario number 1, hf was equals to hf naught. F naught is the threshold frequency you can see over here. So we can plug the value here. What do you think? 2hf is equals to hf naught plus hf, which means now the kinetic energy of this is hf, which is according to the question is written as k. So here we are now with the energy of a photon of the frequency 4f. It's a blue light, monochromatic. Of course it will have a minimum wavelength within a among these three lights, so it will hit this electron, this electron will come out. Now what will be the kinetic energy of this photoelectron? Let's find out. So let's apply again the photoelectric equation. For hf is the kinetic energy, is the initial energy, incident energy is equals to the work function, that is same, that is equals to hf, that we can write here is better, hf plus the new kinetic energy of this electron. And what we see, this is the 3hf, and the hf is equals to k. So if we plug the value here, so it means that the 3k is the kinetic energy of this photoelectron when the frequency of 4f photon will incident on the same metal plate. So the right answer of this question is C.